So now that we've done an example with the source editor, and I've given you an example of a shelf tool, I'd like to move on to the examples of the Python nodes. There's going to be two Python nodes that we're going to be working with. I am going to use what you might consider a Python Wrangle node. It basically works the same way as a vex wrangle. It takes the input, it does to that input whatever you have written in your code, and it gives you the output as a result on the other side. We will also construct, as another example, a manual Python node, which is basically a modified null with a Python window on it and a button that lets you run the code, which requires you to press the button rather than running the code automatically. Let's have a look at the first example, which would be the Python Wrangle. So in this scene that we have all these nodes. The first one is called Python Wrangle. If you jump inside there, you'll find a box. That's all it is, just a box. And a scatter node underneath it. I basically just want to show you how a Python node works. So if you would do tab Python, you will get a Python node. You can then type Python code in there instead of vex. It works the same as if you would do a point wrangle. It's the same basic principle. It gives you a window in which you type your code and then performs whatever you code in there on the geometry that's coming in and then outputs it on the other side. I tend to just leave these lines in there. Node is who.pwd and geo is node.geometry because this simplifies the code we have to type going forward. Now if we look at the points, we can see they're all black. If we middle mouse on the Python node, all we have is a point attribute for position. But let's go ahead and add an attribute through Python. We're going to add a color attribute, so let's just call it color underscore attrib. Then we say is geo, so instead of node.geometry, we can just type geo because it's been specified at the top for us. And then we say .add attrib, which is a function that lets you add an attribute on the geometry specified by geo. And then inside here, we're going to have to type a bit more. We want to specify that we're creating a point attribute, which we can do by typing who.attrib type. You can see that it's trying to fill it out for you already to give you a hint, a bit of help really, to help you get there. And then we do dot. So here we can choose global, prim, vertex. In either case, we want to do a point attribute. So we choose dot point, and we're going to close that off with a comma. We're going to call the attribute cd, of course, again with a string value. And we also need to give it a value. So let's just say we give it a value of 0. Now you see that they're all black. If we go to the spreadsheet, we can see that we've given our points the cd attribute with an integer value of 0. Now if you set cd to 1, they just become red. cd is a vector attribute, not an integer attribute. What Huni does is if you set a vector value with a single value, it simply adds that value into the first of the 3 vector values, in this case the R value for RGB, and it ignores the G and B values. We could also pass in a single float value and set cd to 0.5. Now cd is a float instead of an integer, and makes the points half red, if you will, again ignoring the other 2 values for green and blue. We want to give cd a vector value. So we're going to open and close brackets, and we're going to say 1.0, 0.0, 0.0. What this does is create float values, 1 for each channel. Now it knows what value to give to each of the RGB values. So red is 1, green is 0, and blue is 0, making it red. We could also do 0.0, 1.0, and 0.0, making them green. Of course, we want to do a bit more, so I want to give you a wider example of how we could edit this node and make it artist friendly and do something with the points driven by your code. Let's do that in the next video.